Now that we know the basics of modelling with Fusion 360, we need to know how we can use these tools and others to design a part for additive manufacturing. Unfortunately, just because you can model something within the software does not mean it is necessarily best suited for 3D printing. There are manufacturing constraints of the technology, which means we may need to make edits to models, or bear these constraints in mind when first designing and modelling. There are a number of different areas to consider, and the details of these will depend on the specific printer you are using, but we'll cover some of the general points now. One of the main considerations for an additive build is which faces of the model will need to be supported. Generally, if building directly upwards, the face won't need support structures, and this is also the case when building out at an angle, called the overhang angle, up to a certain value. If you go above this angle, then the print won't be able to support itself, and some kind of support structure will be needed. You may want to ensure that this critical overhang angle is not exceeded to keep support use to a minimum, maybe to reduce material use or post-processing time. When designing with Fusion 360, you can do this by making sure any sketches that are produced don't create angled faces over this value by making use of the dimension tool, or you could use the draft tool to set the angle of faces, ensuring not to go over the critical value. The draft tool can be found in the modify list of solid modelling tools, and you simply need to define the pull direction, which is what the angled faces will be relative to, and then the face or faces themselves to draft. It's worth remembering, like all operations, a draft will appear in the timeline, so the value can always be changed later on. Something else to consider when designing are the features that will be on the model. Certain features will print better than others. For example, sharp edges or corners should be avoided, as these are more prone to warping. The fillet tool is a very easy way to replace any sharp edges with a radius. As we've already seen, the fillet tool is found in the modify list. The exception to this rule is if the fillet is curving onto the build plate. Then instead, a chamfer should be used to prevent warping off the build plate. The chamfer tool is also available from the modify list and works in a very similar way to fillet. Simply select the edge or edges to apply the chamfer to, and set the value by entering a number or using the interactive arrow. There will be a minimum detail size that is achievable for your print, and this value will depend on the details of the specific technology and machine being used. Whatever this value is, you can use Fusion 360 to check your model is not below this and edit it if needed. The easiest way to check for this is by using the Measure tool available from the Inspect panel. With this tool open, you simply need to select the faces or points and it will show you the distance in between. It will also show you the radius of any curved surfaces, such as holes, which you may need to ensure are not too small so that they will not seal over in the print. If this value is shown as below your minimum detail size, the easiest way of editing the model is by using the Press Pull tool. This is also in the modify list and works in a similar way to the Extrude tool, except it will also work for curved surfaces. With the Press Pull tool, you can select any surfaces and offset these, which is very useful for quickly adding on material. For certain small features, it might be better to simply delete these from the model, rather than trying to print them, which might just add time or support structure use. This can be done very easily by selecting the relevant faces and pressing Delete on the keyboard. Fusion will then automatically fill in the material. The delete operation will appear in the timeline, so you can always delete the delete if needed. Rather than focusing on individual features, it might be necessary to make edits to the entire model. In all additive methods, there will be some form of warping and shrinkage as the material cools, meaning models may appear to be printed under size. To correct for this, you may want to edit the model to adjust for shrinkage. One way of doing this using Fusion 360 is by using the Scale tool. This will scale a model by a factor which can be calculated by printing a test part and measuring features' printed size against the nominal CAD dimension. From this, you can work out the correction factor, which can be used for future prints using the same print parameters. Depending on the size of your model, it might not be possible to print it in one piece if the build plate of the machine is not large enough. In this case, you might need to break the model down into smaller parts, which can be done using the Split Body tool. For this, you may need a plane to use as a splitting tool. Planes can be created from the Construct panel. The easiest is an offset plane, with which you can position the new plane relative to another. Once this is created, using the Split Body tool, you simply need to select the body and this plane, and the model will be cut in two. These two bodies can then be printed separately or split down further if needed. For a summary of these points, along with a few others, make sure to check out our Design for Additive Manufacturing Guide document.